Hi everyone. This lesson is for geometry students. This lesson is for to find the areas of trapezoids as well as regular polygons. And then we're going to review a little bit of the other day when we were finding the polygon measures of the angles, and interior and exterior. So we're going to start with this problem here. It says, how many sides does a regular polygon have if the measures of each exterior angle is 60? So in this problem right here, I'm going to make a little facade of my polygon. And so my exterior angle would be out of my polygon. And so this right here would be the exterior of the polygon. That would be 60 degrees. Now, the sum of all the measures of the angles of an exterior, all the exterior angles of any polygon is 360 degrees. So realistically, all we're going to do is go 360 divided by 60 degrees, and that's going to give me 6, being 6 sides. So this polygon has 6 sides. For this one right here, it says, how many sides does a regular polygon have if one exterior angle is 15? So again, here's my exterior angle. This exterior angle is 15 degrees. So therefore, again, 360 degrees, because the sum of all the exterior angles all the way around is 360 degrees. If I divide that by 15, I am going to get, what? 360 divided by 15. I get 24. And so that means I have 24 sides. For this problem here, when you make a sort of facade, this one is 120 degrees. So my exterior angle is actually going to be pretty large. 120 degrees, that's my exterior angle. So I'm just going to make sort of a facade going one way like that. And what that looks like is, again, you're going to go 360 degrees divided by 120. And that does make 3, being 3 sides. Now, I mean, use your intuitiveness. What you've got here is, that if the outside angle is 120 and this is a straight line, which means all lines are, those angles are supplementary. And so that would make this angle, interior angle, at 60 degrees. And if my interior angle is at 60 degrees, and I know that this is a regular polygon, that would mean that this regular polygon, all of those angles have 60 degrees. So this actually is a triangle. And so, a lot of these things are just going to come to you as you go. And you would know that that has 3 sides because it's a triangle. These problems here say, how many sides does a regular polygon have if the measure of each interior angle is 60? Now, we just did this one, so we know that this one has 3 sides. However, I do want to work this out in that I'm going to make my little facade here. And again, if the interior angle is 60 degrees, that means the exterior angle is 120. And absolutely, you can always go 360 divided by 120. And that's going to be 3, being 3 sides. The other way to do this is to use your formula that you have, that for one angle, in a regular, this has to be a regular polygon though, because that would make all the sides and angles equal. So therefore you can just divide it by that many, right? So this is equal to 180 times n minus 2 divided by n being the number of sides. So if I know one angle, and this is the interior angle, is 60, I'm going to go 60 equals 180 times n minus 2 all over n. I'm going to multiply by n here, and I'm going to get 60n is equal to 180n minus 360. I'm going to move this value over here, 360. I'm going to move this 60n over to be with the 180, and that what? 120n. Divide by 120, n is equal to 3. So that means I have 3 sides. So again, you absolutely can do this. This is the work for this problem. Or you can use the exterior angles, which is, I think, a little bit quicker, but I mean, it's your preference. So I'm going to make, for the next problem, a little facade again. And for this problem, it says the interior angle is 160. So I'm going to put that here. So that means that my exterior angle is 20 degrees. And if I go 360 divided by 20, right? I'm going to get, what is that, 18? So 360, sorry, just had lunch and it's caught in my throat. And so I've got 18, so I have 18 sides is the value for this number of sides for this facade of my polygon. For this one right here, this one is saying you have 144 degrees. Again, I'm going to make my facade here, and this one angle is 144 degrees. Here we go. And so this is 144. It's just not writing. And so that means my outside angle, right? My exterior angle is 36, because that's 180 minus 144 is 36. So I would go 360 degrees divided by 36. I'm going to get 10 sides for this problem, because all I had to do was divide, instead of using this formula, which absolutely I could have used, but the other one is just so much quicker. So our learning targets for today are basically to, number one, we're going to review exterior angles, interior angles of a regular polygon. Also, try to find the area of any regular polygon, as well as finding the area of a trapezoid, and how did that come about? How do we get the formula for that? So for this problem here, this is an equilateral triangle. Equilateral triangles because all the sides are equal, which also means that all the angles are equal. So all of these are 60. Additionally, when I drop this down right here, this line is my altitude. And in an isosceles triangle and an equilateral triangle, my altitude will actually come down perpendicular, as well as divide this base into two equal parts. So if it's equilateral and all the way around is 10, that's also 10, and that's also 10, which makes this value on this side 5, and this value over here 5. So that I can find the area, because the area of a triangle is equal to 1/2 base times the height. But very important restriction here, very important, the base must be perpendicular to the height. And so we're going to say the area of my triangle is 1/2 my base. My base is actually 10 units, but my height is what I don't know. So across from the 30 is our A value, which is 5. Across from the 60 is actually A root 3, or 5 root 3. So my height is going to be 5 root 3. So to find the area of this shape, it's going to be 2 divides into 10 5 times. And remember that 1/2 of that quantity, it's not both quantities, just one. So 5 times 5 is going to be 25, and then root 3. And so this is unit squared. This is an area of a triangle, and box that up. You are done. Next problem. Find the area of this figure, not each figure. This is a rhombus. This rhombus looks a little bit off. So I'm going to try to fix that. There we go. So here we go. Here's my rhombus. It has a perimeter of 20. What you need to remember about a rhombus is that all 4 sides are congruent. What that means is that if my perimeter is 20, if I divide 20 by 4, each of my sides is then going to be 5 units. One of my diagonals has length 6. So I don't know which one that is. I'm just going to say it's this diagonal. But what I also know is that if this diagonal, whichever one it has a value, I'll just say this is 6, of 6, this would divide that into 2 equal parts, because diagonals do bisect each other in a parallelogram, which this is. Additionally, the diagonals for this specific special parallelogram is a rhombus, and that has the diagonals perpendicular. So what the benefit of that is that makes this a right triangle. And if you notice that this also is a special, one of our triples, that's a 3, 4, 5. Remember our triples? We have 3, 4, 5, 5, 12, 13, 7, 24, oops, hold on, I just messed up. So 24, 25. So 7, 24, 25, and 8, 15, 17. Right? Let's see. I think that's right. And so where we're at with our area, the area of a rhombus, so the area of a rhombus, and I differentiate this between the other parallelograms by putting a little right angle right there, is 1/2 the length of diagonal 1 times diagonal 2. So for the area of this shape, I'm going to go 1/2 my first diagonal, which is 6. They gave me that value. But my other diagonal, I know this is 4, but that also means that's 4. So that means the length of the diagonal is 8. So I'm going to go 2 divides into 6 3 times. 3 units times 8 units is 24 units squared. And so that's going to be the area of this rhombus. Now to find the area of this rectangle, it says the diagonals of a rectangle are 8 centimeters long. What is important about that information is this, is that if this is 8, diagonals in a rectangle are congruent, they're equal. So if that has a length of 8, also, so does this diagonal. So these values are 8, 8, 8, and 8. Additionally, it says that the diagonals intersect at a 120-degree angle. That's cool because that makes that 120 degrees both sides, up and down, which then makes this angle over here, because that is aligned, 60 degrees. This is not a right triangle though, unless I actually do something like this. And I know this is 120, so if I split this up like this, right? What that's going to do for me is that's going to make this little angle here 60 degrees. And what the benefit of that is that that's going to be a right angle. And I know that if across from the 90 degree in a 30, 60, 90, and I'm not using this 60, so I'm going to erase that first. 30, 60, 90 is equal to 2a, which means if 8 equals 2a, a is equal to 4. So across from my 30-degree angle, I have 4. And across from my 60-degree angle, I have 4a. It's a root 3. So this would be 4 root 3. And so why that is great is because the area of a rectangle, to find the area of a rectangle, it's base times height, where the base and the height, of course, are perpendicular. And you know that because all rectangles have right angles there. So the base is 4 root 3. That's that value, plus 4 root 3, which makes 8 root 3. So the base is 8 root 3. And then the height is this value, 4. See how that goes up? And then 4 plus 4, 8. And so that's times 8. And so the area of my rectangle is going to be 8 times 8, which is 64, and then root 3. And this is the area, and this is units squared. So here's some like a review of the formulas that you have been exposed to. We've learned these. You know, area of a rectangle, base times height, length times width. All of these, just for your information, reference, all of these have the base and the height are perpendicular for every single one of these. It's really, really important that you make that distinction, because here base and height are perpendicular. Here's my base and here's my height. They have to be perpendicular. My base, so this one here, see that? Those are my diagonals. They do have to be perpendicular. Here, my base and my height, also perpendicular. Base and height, also perpendicular. Very important there. There's the formulas. You can look those up and just have those as a reference and then sort of add to them as we go through the chapter. Find the area of this isosceles triangle that has a base 10. Now, again, this differs from the first problem that we did because while we are going to split this up down here, because, of course, to find the area of a triangle, it's 1/2 the base times the height, where the base is perpendicular to the height. Very important. So I didn't have a height, so I drew one in, auxiliary line. I drew one in, and now that's perpendicular. That makes this length 5. Now, it's not a 30, 60 90 right triangle because, right, this is 46 up here, not 60, and it's isosceles, not equilateral. So that means that this is 46 here, but it's split in half, which makes that angle here 23 degrees. And I can go 90, subtract 23, and that gives me 67 degrees for that other angle right here. And if I'm standing here at this 67 degree angle, and I'm trying to find h, my height, because I already have my base, right? My base is 10. I'm trying to find the height. I'm going to use trigonometry. And so these are the two values that I'm concentrating on. So that's going to be tangent, because that's opposite and adjacent. So I'm going to say tangent of 67 degrees is equal to the height, which is what I'm trying to find, over 5. So the height is equal to 5 times tangent of 67 degrees. So tangent of 67 degrees is 2.355. And then I'm going to multiply this number, 3,558, and then that's what, another 5. I'm going to multiply this value here by 5 to find my height, because in order to find the area, don't lose sight of what you're trying to find. In order to find the area, I have to have the height. So I'm going to take this value and multiply that by 5, and I'm going to get 11.8. So this is about, because I rounded, 11.8, so my height. So now I'm going to take this and I'm going to bring it down right here, because now I need to find the area. Remember, area of the triangle is 1/2 my base, which is 10, times my height, which is 11.8. And so now I'm going to take 11.8, I'm going to multiply that by 10, divide by 5, and I get 23.6. So the area of my triangle is 23.6 units squared. All right, so another rhombus problem, we just did this. The diagonals of a rhombus are 4 units and 6 units, so that makes that 2 and 2. That makes that 3 and 3. I don't need to find this side here because they're asking me for the area, not the perimeter. So I don't need to find x. What I do need to do is to plug this into my formula. So the area of a rhombus, and again, I like to put a little right angle there, is 1/2 diagonal 1 times diagonal 2. So we're going to say the area is going to be 1/2 4 times 6. Half of 4 is 2. 2 times 6 is 12. The area of this rhombus is 12 units squared. So what happens here as we introduce the area of a trapezoid, what is happening is there's a couple of things that can happen here. Number one, the area of a parallelogram is just base times height. However, your base and your height have got to be perpendicular. 100%. No exclusions, always. But for a trapezoid, it's sort of like the sum of the parts. The formula for the area of a trapezoid is area of a trapezoid is equal to the height divided by 2 times the sum of the bases. All right. But realistically, I mean, a couple ways to think of it. You could think of it as a parallelogram, possibly, if you drew it right? You could think of it as a parallelogram plus a triangle, or you could also think of it as a triangle here, a square in the middle, and then a triangle here. So really, it's 2 triangles plus a square. There's lots of different ways you can do that. However, I want you to remember this formula, and I want you to remember this formula for the area of a parallelogram and the area of a trapezoid, because we're going to be using those right now. So to find the area of this trapezoid, remember, an area of a trapezoid is the height divided by 2 times the sum of the bases. And so my height is always going to be perpendicular with the base, okay? So my height is 3. So that's 3 divided by 2 times the sum of the bases, so 5 plus 8. And so 5 plus 8 is 13. I get 3 times 13. So hold on. So I'm going to write this out. The area of my trapezoid is 3 times 13 and then divided by 2. So 3 times 13 is, of course, 39. Divide that by 2. And so the area is going to be 19.5 units squared. And remember, area is that space inside. So that when you're looking for, if somebody's saying, hey, what's this area? It's a two-dimensional surface of the height. It's a height inside of, whatever shape it is that you're looking at, okay? For this problem, I just wanted to touch base. This is not the area, of course, but I wanted to touch base on how to find the median of a trapezoid. And that median is that middle length right here. It's this line right here that actually connects two midpoints. It connects the midpoint on this side, so that means a midpoint does cut that in half. And then it also connects the midpoint here on the right. So the way you would find the median formula, or the length of the median, is to use that formula. The median is equal to half the sum of the bases. So it's going to be base 1 plus base 2 divided by 2. Now, this does look really familiar, doesn't it? It almost looks like the area formula. The area formula, which said the height divided by 2 times the sum of the bases. But this is not. This is different. This is area here, and that's the median, or that mid-segment that cuts each of the sides in half. So that's a length. So if I said that was 10 and that was 20, that length, the median length, or M, would be 10 plus 20, which is 30, divided by 2. So my median length would be 15. So for these, we're back to area. We're going to do 2 more examples of the area, finding the area, before we move on to polygons. So the area of the trapezoid. So again, the area of our trapezoid is going to be height divided by 2 times the sum of the 2 bases. And so for this problem, I see that my bases, height, I don't have the height yet, but the bases are going to be 15 plus 30, okay? So in order to find the height so that I can find the area, I'm going to use this very, very special right triangle on the left here, and across from a 60-degree angle, right, is a root 3. Across from the 90 in a 60, 30, 90 triangle is equal to 2a. So if 2a is equal to 12, then a would equal 6. So that means across from the 30, which is up here, is 6. And then across from the 60 would be 6 root 3. So that value, 6 root 3, is my height for this problem. So then what I can do is, remember, numbers get canceled with numbers. So this 2 can cancel with that 6, not with the root 3, but with the root 6, and that would leave me 3. So that would give me 3 root 3 times 45. And then so my area is going to be 45 times 3, right? So that's, I believe it's 135. And that value, 135, is going to be root 3. And that's units squared. Now, of course, you can estimate what 135 root 3 is. And so that value as a decimal is about 233.8. So the area is about 233.8, and again, units squared. But if I ask you what the exact value is, that's this value without a decimal. For this problem here, I'm looking for the area again. And for this problem, I want to find the area, and I have no other information. This is a little bit tricky, definitely. But what I do know, that it is isosceles. And why is that helpful? That is helpful because, I'm going to open this up just a little bit if I can. I'm not sure if I can. Because this value here, if I bring this straight down, perpendicular. Also, if I bring this down perpendicular, these values down here are going to be the same because it is isosceles. So what that is why that's beneficial is because that means that length from here to here is 7. And if I go 23 subtract 7, I get 16, which means that each of these lengths on the side are 8. And that means that I can use Pythagorean theorem. 8 squared plus my height squared equals 17 squared. 8 squared plus the height squared equals 17 squared. Remember to make sure that the hypotenuse is always by itself. But I also recognize that this is one of our Pythagorean triplets, which is 8, 15, 17. So I do know my height is 15. Again, they're very beneficial to remember what they are. So the formula for the area of this trapezoid is going to be the height divided by 2. So 15 divided by 2 times the sum of the bases. So 7 plus 23. So 7 plus 23 is 30. And then remember, that's 15 divided by 2 equals that area. And so 2 divides into 30 15 times. And so the area of this trapezoid is going to be 225 units squared, which is 15 times 15. Okay, so now we're going to move on to finding the area of regular polygons. So a regular polygon, remember, we talked about this in the beginning of the period, is a polygon that has all sides congruent, and therefore all the angles are congruent. All right. Additionally, the square is a polygon because all my sides are congruent and all my angles are congruent. This right here is a pentagon, but also all angles are congruent, all sides are congruent. And so why that's important is because I'm going to be able to use this information to find the area of my polygon, and this is going to be my formula. I want you to write this down. The area of any polygon is equal to 1/2 ANS, or the area is equal to 1/2 AP. And I abbreviate AP because the number of sides times the length of a side is the perimeter. So that's what that is. But given this information, let's talk about what these letters mean. Okay. 1/2 fraction. A is what we call our apothem. APOTHEM. Some people call it an apothem. That almost reminds me of an animal running around. Or apothem or apothem. N stands for the number of sides. So that's the number of sides. And lastly, the S stands for the length of one side. That's what that stands for. So ANS, 1/2 ANS. Now, a lot of kids have never heard of what an apothem is, or apothem. An apothem is like a radius, or except for it comes, instead of going to the corner like a radius does, that's an R, it comes straight down, perpendicular with the base. In a triangle, this is 2 to 1 here, so there's like 2 to 1 of those. But in a square, the apothem comes straight down, also perpendicular. This is only half of that length. So an apothem comes straight down. That's your little a. That's your a value right there. And in a pentagon, again, comes straight down, perpendicular with the base. That's my apothem. Now, the number of sides, you would just count 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. And the length of the sides, keep in mind, because they are regular polygons, all the sides and all the angles are congruent. So that means if this was 10, that's 10, that's 10. If this is 8, that's 8, that's 8, that's 8, etc. In a square, by the way, the apothem is pretty easy to find because, see, a square, an apothem is half the value of whatever the length of a side is. Whereas this, if I know my altitude in my triangle, my apothem is a third of that length, because this could be divided into 3. So we're going to get to all the different things here. So already regular polygons, by the way, can be inscribed, put into a circle. What is important is that you remember that if a shape, a polygon, is inscribed in a circle, that the vertices all touch the edges of the circle. Okay. This value here, that's my apothem. Remember, that comes down perpendicular. Anything that goes from the center of your polygon to a corner or one of your vertices, we call that a radius. And then we also have something called a central angle. Now, a central angle starts at the center of your shape. It could be a square, it could be, whatever it is. So like if I drew a square, from my apothem, I would go to each corner, right? Like that. And those are my radii. Radius is more than one radius or radii. This angle that is at the center, right, especially if this was inscribed in a circle, this angle right here is what we call my central angle. A central angle is an angle that has the center, that the angle is the center, the vertex is the center of the circle. So this value here, this angle is a central angle because it has the center or the vertex at the center of the circle. Okay. What's cool about this, by the way, is that if this angle, by the way, is, let's say, 50 degrees, then this arc length right here also 50 degrees. Okay. We'll get to that more later. So where we're at here is your job is to find the area of this hexagon. A hexagon, remember, has 6 sides. The formula for the area of the polygon, okay, and so I guess I'll just make this into a hexagon. So 1, 2, 3, 4, 5, 6. So the area of our hexagon, we're going to use this formula, 1/2 ANS. That's apothem times number of sides times length of the side. So a couple of things we actually already know. Number 1, we know the number of sides. We know this because it has 6 sides. So that's going to go right here. Additionally, they just told me that the perimeter is 12. So if my perimeter is 12 and I have 6 sides and the perimeter is 12, I'm going to take 12 and divide by 6. And when I divide 12 by 6, I get 2. So the length of each of my sides is 2. So that's S, which is 2. Now, the most tricky part, I would say, is to find the length of the apothem, which is this length straight down. Remember, perpendicular. And so in order to find that length, that apothem, that A value, okay, what I'm going to need to do is use the information that I know about a hexagon and the angles inside. So what we learned the other day about the angles of a hexagon are this. We learned that to find the sum of all angles in a hexagon or in any polygon, right, is equal to 180 times n minus 2. So n being the number of sides. So 6 minus 2, which is 4, and 180 times 4 is actually 720 degrees. So that means that if I add up all the angles in my polygon, I am going to get 720 degrees. Now, because this very, very, very important information is here, and it says this is regular, what that means for us is this, that I can take 720 and divide by, how many sides do I have? I have 6 sides. So if I divide by 6 sides, then the one angle that's interior, so one interior angle is equal to 120 degrees. So that means this angle is 120. This angle is 120. This angle is 120, etc., all the way around. And that means that if I take my angle here and I split this up like that, this angle is then 60 degrees, which means so fun that I have a 30, 60, 90 right triangle within my hexagon. And then if I know that this length of one side is 2, that would mean 1/2 of that is 1. And that would mean across from my 30-degree angle is my A value, which is 1. Across from the 90 is double that, so that's 2. And across from my 60-degree angle would be 1√1√3. And that value right here is my A value, or my apothem. So we have 1√3 is here. So to find my area of my hexagon, I'm going to go half of one of these numbers. Okay, so I'm just going to take half of 2, which is 0, or 1, which is gone now. 1 times 6 is 6. So we have 6√3 units squared. And so that is my area of the hexagon. Know this. I'm going to ask you this on your test. So for this problem here, I want to find the perimeter and the area of this regular hexagon, another hexagon. We love hexagons because they make the coolest little corner angles here. And so my apothem is telling me that that is 6. So I'm going to make my little right triangle here because, again, we know already, right, that this right triangle is a 30, 60, 90. Because when I split this 120 up, that makes that 60, okay? So we've got the 60, 30, 90. This value is 60. This value is 30. I want to find the area and also the perimeter. So let's put the formula for the area down first. The area of the hexagon is going to be 1/2 ANS. And so 1/2 my apothem, which we already have, is 6, times the number of sides. Well, if this is a hexagon, this has to be 6. And then the length of one side, which I don't know yet, but we will find out. So across from the 60, remember we call this A√3. So then in order to find just A by itself, we would divide 6 by √3. But again, don't leave a root on the denominator. You're going to multiply this by √3 over √3. So that's going to give you 6√3 over 3. And that right there is actually going to reduce to 2√3. So the length of my A value, which is across from the 30-degree angle, is going to be 2√3. So what that means, and I'm just going to bring this down just a little bit, and what that means is, okay, and I know the A's might, I don't know, maybe the A's get you a little confused, I'm not sure. But with this value, I know across from the 30 then is 2√3. So that then means that if I were to take that value and double that, now I have 4√3, and that is the length of my side, okay? Okay, so then what do we do with this now? So I got to multiply it out. So let's see. We're going to go half of 6 is 3. 3 times 6 is 18. 18 times 4 is 36. 36, which is what, 72? So we have 72√3 units squared. And this is the area of my hexagon. Now, lastly, we have to find the perimeter. So we know that each of my sides is 4√3. So what I'm going to do is take 4√3 and multiply that value times 6, since I have 6 sides. So 6 times 4 is 24. So my perimeter is going to be 24√3 units. Not units squared, just units. For this problem here, I'm going to find the area and perimeter of this square with a diagonal length of 10. So I know that this length here is 10. We also know that these two sides, whatever they are, the length are equal. To find the area of a square, you're going to find that value side, and you're going to square that. And the perimeter is just 4 times that value. So in order to find the length of one side, you have options. You can use the shortcut, or you can use your formula for Pythagorean theorem. where you just make one of these values x because they're the same. So if I did that, I would go x squared, because it's leg squared plus leg squared. X squared plus x squared equals my hypotenuse squared. 2x squared is equal to 100. X squared is equal to 50. And if I square root both sides, I get x is equal to, and 50 is going to break down to root 25 times root 2. So x is equal to 5 root 2. So that's the length of one of my sides. So now the length of one of my sides, all of my sides, is 5 root 2. So to find the area of this square is going to be equal to 5 root 2 quantity squared, which is actually 5 root 2 times 5 root 2. And that's 25 times 2, yep, you guessed it, 50. So that's the area of this square, and this is unit squared. The last part of this problem is asking me for my perimeter. And again, remember that the perimeter of a shape is the sum of all the sides going all the way around. So we have 5 root 2 plus 5 root 2, that's 10 root 2. Add another 5. So it's like here you are, and you're basically walking around the space here, going all the way up, sort of like a Pac-Man, picking up all these 5 root 2s, right? So you've got 5 root 2, 5 root 2, 5 root 2, 5 root 2. 5 root 2 4 times makes 20 root 2. So the perimeter is 20 root 2, and that's just units. For this problem, this is another hexagon problem. I know we love hexagons, right? Again, 1/2. So the area of this hexagon is going to equal 1/2 ANS. A times N times S. We know that one of my sides is 12, which means that when I put my apothem in and I bring it straight down, this length is 6. I'm going to bring this in the corner here, again, 60 degrees, because that was 120, cutting in half. That makes this a 30-degree angle. Opposite the 30 is our A value, which please don't confuse with your apothem. So this is 6. Opposite the 90 is twice that, which is 12. And opposite the 60 degrees is your A root 3, or 6 root 3. Fun fact, that if you notice that this side, these radii are values of 12, there's like these little mini equilateral triangles within these hexagons. Also very cool. Anyway, the area of this shape, this hexagon, is my apothem, 1/2 my apothem, which is 6 root 3, times the number of sides, 6, times the length of one side, which is not 6. The length, remember, is this whole length from here to here. And so that's 12. And so we're going to say 1/2 of 6 is 3. And I'm going to go 3 times 6, which is 18. And 18 times 12 is 216. So my area of my hexagon is 216 root 3 units squared. And most of the answers I will expect you to put in exact value, which means there's no decimals. However, if you wanted to know what this was, 216 root 3, the value, approximate value, you would write it like this. The area is approximately 374.12 units squared. To find the area and a perimeter of this equilateral triangle, this one definitely, the apothem comes down a little bit low because the apothem here is 8. What you need to remember here, this being a 60 degree, and there's a couple ways to do this, okay? All right. One way to do this is we know that all the angles are 60. When I bring in my radii and I come down here, that 60 is then cut in half. 30, that's a 90. That makes us up here a 60. And across from the 60, across from the 30 is our A value, right? And that's 8. Across from the 60 would be 8 root 3. So the length, so one way to do this is to say, well, the length of one side here is 8 root 3 plus 8 root 3, and that makes 16 root 3. So that's the length of one side. Now, the other thing that you need to know is the height. And because in order to find the area, well, let me say this. If I were to use, because this is a polygon, definitely, and it's regular, the area of this polygon would be 1/2 ANS. So the area would be 1/2 my apothem, which is 8, times the number of sides, 3, times the length of one side, 16 root 3. So 16 root 3. So the area of this shape is going to be, 2 goes into 8 4 times. 4 times 3 is 12. 12 times 16 is 192 root 3, and this is units squared. Now, that's the area of my shape. That being said, I also could find the area this way and say, well, I already know the area of a triangle is 1/2 base times height, and I like that formula. So I would say 1/2 my base is 16 root 3, but keep in mind that you still need to consider your height. And your height is, if you know the apothem value, which is this value straight here. And remember how I was saying that it's a third. So if that would be 8, this is 8, this is 8. So the length of that height is 8 times 3, which is 24. And in this case, I would go then half of, let's say, 24, which is 12. And again, 12 times 16 gives me 192 root 3 units squared again. So I absolutely have options in finding the area for these regular polygons. The 1/2 base times height works for regular and not regular polygons or triangles, and the 1/2 ANS works for all regular polygons. So you just have to figure out what makes, this makes sense to you, which one works better on a triangle anyways. Now this one is an octagon, which is a little bit different, and I want you to find the perimeter and area of this octagon. And in doing that, again, I'm going to use my area equals 1/2 ANS. So it does tell me that the length of my sides are 5, and this has to be regular, of course, for me to use this formula, and for every side being 5. The apothem is 3, so that's that length right here that comes perpendicular straight down. What is a little bit different is this. My apothem I know is 3. I know my number of sides. Hold on. My apothem they gave me is 3. The number of sides is 8. What they didn't, they did give me the length of one side. Wow, they have 5. I thought we were going to have to find that. They just gave me all the information right there. I didn't realize they were going to do that. I thought we were going to have to figure out what this angle is and use tangent or something like that. Whatever. We don't have to do that. So the area of this shape is half of 8, which is 4. 4 times 3 is 12. 12 times 5 is 60. So we have 60 units squared, and that's going to be the area of this shape. This one, I do like this problem a lot. I'm not sure if we're going to do both of these. Actually, we're not. But I do want to do this problem because this reminds me of the problem that we didn't do on the last problem. So in order to find the area of our trapezoid, going back to this shape, which you're not going to use 1/2 ANS because this is not a regular polygon. Trapezoids do not have all sides and all angles equal. Because if this trapezoid had all of its sides equal and all of the angles equal for this 4-sided shape, it would have to be a square. And this is not a square. So the area of this trapezoid is going to be, remember, height divided by 2 times the sum of the bases. So what we do know, we don't know the height. We do know that the sum of the bases is 7 plus 15. We know that. So in order to find this area, I need the height. So I'm going to drop this down. And the only thing for this problem that they didn't actually tell me, well, they didn't tell me anything other than just that. But I do know that this is a right angle. for that, I can then find the height. It doesn't have to be isosceles because they did give me an angle here. So bringing this straight down, standing right here, I want to find this height. So I'm not going to use tangent because that would give me the length here, but I don't want that. I want h. So I only have the hypotenuse. So what uses the opposite side and the hypotenuse? That would be our SOHCAHTOA. Remember from SOHCAHTOA? SOHCAHTOA. That says sine is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, and tangent of an angle is the opposite side over the adjacent side. So we're going to go sine of our angle, 53, is equal to the opposite side over the hypotenuse, which is 10. And so my h value is going to equal 10 times whatever sine of 53 is. And so I'm going to do that on my calculator and go sine of 53 degrees. Make sure you're in degrees. Sine of 53, and then multiply that value by 10. I get 7.99. So my height is about 7.99. Well, that's not the answer, right? This is just our happy place because we found the height. So, but what we have to do is then take 7.99 and plug it in to the height value right here, see? So we're going to go 7.99. So take that value, 7.99, divide that by 2, get an answer, and then you're going to add 15 plus 7, or you're going to take that value, whatever you got, which I got 3.995, and I'm going to multiply that number by 7 plus 15, and I get 87.89. So that means that my area for this trapezoid is going to equal 87.89 units squared. And so that's the area of the trapezoid, and highlight that, whatever makes you happy, etc. So that, I think for me, we are going to be going over a few of these problems in class, not all of them because it does make this a long day, but just to do one of these, we've done a lot of hexagons. Let's do one of the triangle ones. To find the area of this equilateral triangle that happens to be inscribed, meaning all my vertices are touching this circle that has a radius of 12. So remember, the radius is from the apothem. The apothem goes from the corner straight down. So that a circle, it says find the area inscribed in a circle. The radius is 12. That makes that 12. Keep in mind that these are 60 degrees, right? 60, 60, and 60. But when my radius cuts that in half, that becomes then a 30, 60, 90 triangle. What that does for me is that takes this angle here and says, hey, opposite the 12 to A. A then is 6, that's going to be here. And then across here is 6 root 3. Now, why that is important is because that is my base of my triangle. So a 6 root 3 plus 6 root 3 makes a total length of 12 root 3. And what that is going to do, it says find the area of the triangle. The area of a triangle, remember how we have two ways of doing this. One way is to use our 1/2 ANS, apothem, 1/2 my apothem, which is 6, times the number of sides. It's an equilateral triangle. It has 3 sides. The length of one side, 12 root 3. So 2 divides into 6 3 times. 3 times 3 is 9. 9 times 12 is 96. And then 96 root 3 units squared is the area of my equilateral triangle. And that's all they wanted to know. Okay. Aside from that, there's a few other things just to remember. One of them is that when we're looking at shapes like this and we got to find the missing values, these values, if they're all the same here, they're all the same angle. So this is 1, 2, 3, 4, 5, 6 X's. And this is a hexagon. And the sum of the angles, remember, is 720 degrees. So if I say 6x is equal to 720 degrees, and I divide each, if I divide by 6, that means each angle definitely is 120 degrees. That works if each of the angles is the same. But for a problem like this, not all of these angles are the same. Obviously, that means that it's not regular. Like this one was regular. I can just divide by 6. This angle is not regular. Oh, and let's just say one last thing. If you forgot, like, where did that 720 come from? I mean, I know we just did 4 problems on hexagons, but you forgot. Let's just say you would find the sum. Remember the formula? The sum of the angles, interior angles. So sum of interior or angles is equal to 180 times n minus 2. That's the formula. So you would go 180 times 6 minus 2, which is 4. So 4 times 180 is 720, and that's where that came from. For this problem here, you would just add all the way around. You'd go 138 degrees plus 106 plus m minus 9 plus m plus 133 plus 120 plus m plus 13. Let's see. This is 1, 2, 3, 4, 5, 6, 7. This is not going to equal 720. This is going to equal something else because it has 7 sides. That's right? 1, 2, 3, 4, 5, 6, 7. 7 sides. Because it has 7 sides, I need to use my formula, right, which is 720 plus 180, basically, which is what, 900? And then, or I could do this. I could say 180 times 7 minus 2. So 180 times 5. Yeah, that should give me the same answer. 180 times 5, I get 900. Yeah. So for this, to find m, how many m's do we have? We have 1, 2, 3 m's. So we have 3 m's. We have, let's see, 138 plus 106 plus 133 plus 120 plus 13 is 510. If I subtracted 900 minus 510, I get 390. But I didn't add this in, so be careful. So that's a minus 9 equals 390. So now I have to add 9, so that's going to be 399. And 399 divided by 3 is 133, so m is equal to 133. So there's, of course, different ways to do this problem. Just one option. So lastly, you have a homework assignment. Your homework are these 2 worksheets. Get those done. Stay up to date. Thanks so much for watching, and I hope this helped you with the area of polygons and trapezoids.